right, so 2A is our first unit in Math 143 for the summer. We're going to understand, solve, and explain. Basically, this breaks it down and lets you understand how to do a word problem, how to set it up and organize it. There's a 3-step problem-solving process that we have. The first step is understand the problem. The second step is solve the problem. And then the third step is explain your results. And we're going to go in depth for these. So in the first one, when it talks about understand the problem, the first thing you have to do is really think about what the problem is asking you to do. Is it asking you to find the total? Is it asking you to find the difference of something? And when you find out what this is, this will help you understand how to set it up. Remember that drawing diagrams can often help you make sense of a problem, especially problems that describe something and want you to figure out the other part of it. Ask yourself what the solution should look like. Should it be a bigger number than what you started with? Should it be a smaller number? What units are you talking about? Are we talking about money? Are we talking about time or distance? All of these are greatly important. Try to map a path, either mentally or in writing. Some people, it's easier to organize it on paper so you remember what you're looking for. That will lead you from your understanding of the problem to its solution. So it's basically the same steps over for every problem. As you move on to steps 2 and 3, continually revisit your understanding of the problem. Make sure if you get caught up in doing your mathematical steps in your equation that you're actually going back to answer what they're asking you in the problem. All right, number 2 is to solve the problem. First, you have to obtain any needed information or data. This will be great for you to go through and read the problem, and then what you need to do is actually list every bit of information that's given to you, so you know what you have and if there's extraneous information. For multi-step problems, be sure to keep an organized, neatly written record of your work, which will be helpful if you later need to review or revise your solution. Always double-check each step as you work to avoid carrying errors through to the end of your solution. And constantly reevaluate your plan as you work. Make sure as you're going through and getting these numbers that it's going towards what the problem was asking you for. So that way you don't do a whole lot of work and then realize you were going in the wrong direction. Number 3, we want you to explain your results. Be sure that your results make sense. If it's a distance, it can't be negative because you don't ever travel in a negative distance. If it's time, it can't be negative either. Make sure that it is something that when you're reading the problem and they're asking for something that the amount or the number is logical of what you've got. Once you're sure that your result is reasonable, it is a good idea to recheck your calculations. Once more, or even better, find an independent way to check your results. What they're saying here is if you get your answer, find a way to plug it into the information that you have and see if it makes sense. Identify and understand all potential sources of uncertainty in your results. Okay? Sometimes when we do math problems, things can interfere with it, or it could not make it a true statement, like predicting the population growth. Something could come up and it would stop the growth as we say it's going to be in a linear fashion. Write your solution clearly and concisely, using complete sentences to make sure the context and meaning are clear. Here is where you start realizing that when you're doing these solutions and you're getting a number for an answer, that number actually stands for something. You want to make sure that you're understanding what your number means. All right, units are very important. When you write out your answer, you can't just write the number. I need to know, is that minutes per day? Is that money that we're talking about? Is it time? Did you change kilograms to grams? There's all kinds of things that we have. I've also included in this folder a sheet of conversion for units that you would use, and there's more on there than you're going to use for this class, but a lot of them will be great when you take chemistry and other stuff like that too. The units of a quantity describe what that quantity measures or counts. Unit analysis is a process of working with units to help solve problems. So when we do unit analysis, this helps you to actually convert things. If I want to know how many minutes are in a week, I will have to convert the days to hours and then to minutes on that one. Example, using keywords. You are buying 30 acres of farmland at $12,000 per acre. What is the total cost? All right, so the first step is the question asked about total cost. All right, how much did you spend in all? One of the given units is dollars, so we actually expect the answer to be in dollars. So when you're looking at total cost, we're not asking about how many acres they bought. We're asking about how much money they spent when they bought the acres. The keyword suggests multiplication, and we realize that we can end up with an answer in dollars by multiplying the acreage by the cost per acre. So you bought 30 acres. That's what we have up here. You paid $12,000 per acre. So this is $12,000 per acre over 1 acre. And we multiply that. So they ended up, total cost to them was $360,000 for their 30 acres. Notice when you're multiplying here, this 30 acres is understood to be over 1 because it's 30 acres total over 1. So the acres, because this would be in the numerator and this would be in the denominator, cancel, leaving your answer in just dollars. We have found that the land cost $360,000. Note that the answer has come out with the units we expect. These are your units, dollars. Unit analysis and problem solving. Remember, you can't add or subtract numbers with different units, but you can combine different units through multiplication, division, or raising to powers of stuff. It is easier to keep track of units if you replace division with multiplication by the reciprocal. For example, instead of dividing 60 seconds per minute, multiply that by 1 minute and 60 seconds. Let me move this down so you can see. When you complete your calculations, make sure that your answer has the units you expected. If it doesn't, then you've done something wrong. Now, that means that you could have set it up wrong. You could have put the wrong units in the order. Things like that. It doesn't mean that you've done your multiplication wrong. It could just be a setup. All right, keywords and operations in units. For example, if you hear something per, like that one was $12,000 per acre, that's division. All right, that reads miles divided by hours as miles per hour. So if you hear something like they went 50 miles per hour, that's actually 50 miles divided by 1 hour. They went 50 miles in 1 hour. Of, or if you have a little hyphen in between it, that means multiplication. So for example, you could read kilowatts times hours as kilowatt hours. So if you see this little part right here, it's written like this. You're going to multiply how many kilowatts there are and how many hours there were. So this is kilowatt hours, and not, instead of kilowatts, per hour. Square. When you have the square in your wording, it means you're raising it to the second power. So if you read feet times feet, that would be feet squared as square feet or feet squared. This is when you're like finding the area of something, because you're going to multiply the feet in the width and the feet in the length if it is a rectangle. Cube or cubic, you're raising it to the third power. This is usually used for volume. So that would read feet times feet times feet, which would be feet cubed as cubic feet or feet cubed when you're looking for these words. All right, let's do an example. Using units to find a pathway. How many crates do you need to hold 2,000 apples if each crate holds 40 apples? Okay, so you know you got 2,000 apples, and you want to know how many crates you're going to have to put all those 2,000 apples in. You also know that each crate holds 40 apples right here. The question asks how many crates, so the answer should be in units of crates. Notice that the statement, each crate holds 40 apples, implies that we can fit 40 apples per crate, right? Here's your key word, and that means division. So then we would write it 40 apples per crate, which means divided by a crate. 40 apples in 1 crate. So if we have 2,000 apples and we have to divide it by 40 per crate, but we're going to have to flip this, right? Because if you look down here, 1 crate also equals 40 apples. But see, this unit is apples, and that's what you want to cancel, so you're in crates. So we flip it and put 1 crate on top and 40 apples on the bottom. And that way we're going to come out with the units of crates that we want, because apples here will cancel apples here. So then that would be 2,000 divided by 40. Apples cancel, and I get 50 crates, or how many I'm going to use for 2,000 apples. Now, I know some of you do this in your head and you're setting this up and this is just too complicated. I can do it easier on my calculator. I knew that I was going to take 2,000 and divide it by 40, and that's fine. But when we start doing unit analysis and you get into something called stoichiometry, you could be converting several different times. So you need to make sure you have it organized and you have it in the right way to make sure that the units come out the way they're supposed to. Conversion factors. A conversion factor is a statement of equality that is used to convert between units. This is when you're looking at things like how many days are in a week. 1 week equals 7 days. How many hours in a day? 1 day equals 24 hours. Okay, some other conversions that we're looking at if you're looking at metrics. There are 12 inches in 1 foot. Now that means 12 inches equals 1 foot, or you can write it as 12 inches over 1 foot because these two are exactly the same thing and that equals 1. Or you can flip it. This is what's so great about your conversion factors because they equal each other and it doesn't matter which order you put it in, but you have to decide on which ones have to be canceled. All right, here's the 24 hours in 1 day. So you can write it as 24 hours in 1 day, or you can write it as 1 day equals 24 hours, just depending on what units are given and where you're going with it. All right, let's do an example. Feet to inches. They want you to convert a distance of 9 feet into inches. Well, first of all, we already know that there are 12 inches in a foot. But we know we're going to start off with 9 feet. So you'll always put up here at the very beginning what you're starting with. We're going 9 feet. Now we want to change this to inches, so we want to cancel out the feet. So our conversion, since the 9 feet are here, we want feet on the bottom. So that means in 1 foot, we're going to have 12 inches. And we cancel, and then we'll multiply straight across. 9 times 12, so you get 108 inches. So that means 9 feet equals 108 inches. Another one, let's use a chain, or something they call stoichiometry in chemistry. Using a chain of conversion. How many seconds are in 94 days? Now we're going to have to convert from days to seconds. So in 1 day, there's 24 hours. In 1 hour, there's 60 minutes. And in 1 minute, there's 60 seconds. So we're going to have to convert from days to seconds, and we're going to have to use all of these conversion factors. So always, the one you start with is your first one, 94 days. So we're going to want to cancel days. So here, between days and hours, days will be on the bottom. So 1 day is 24 hours. So days will cancel, and our answer will be in hours, but we don't want hours. So we're going to convert again. In 1 hour, there's 60 minutes. Because we want to cancel this hour, the hours go on the bottom and the minutes go on top. So these hours cancel. But then now we want to convert the minutes to seconds. So we're going to put 1 minute equals 60 seconds here. So the minutes cancel, and if you'll notice, all the units canceled except for seconds. And that's what we wanted it to be in, because it says how many seconds are in 94 days. Because all of these numbers are in the numerator, you're going to multiply. So you're going to do 94 times 24 times 60 times 60, and we get 8,121,060 seconds are in 94 days. Conversions with units raised to power. Okay, 1 yard is 3 feet. 1 yard squared would be 1 yard times 1 yard, which would be 3 feet times 3 feet. So 1 yard squared is 9 feet squared. Be very careful when you're using these conversions that you also square in your, when you have your basic conversion, that you also squared to do it if it's to the second or to the third. Okay, so basically here, this is 1 yard. There's 3 feet. This is also 1 yard. So if you're doing 1 yard by 1 yard, you're going to, and this is a rectangle, which is also known as a square, you're going to multiply this by this. So you're going to do 3 feet times 3 feet, which is 9 feet squared, because feet and feet give you squared. Let's do an example, because you're going to cover, you're carpeting a room. So you're going to cover the floor. So this is the area of it. You want to carpet a room that measures 12 feet by 15 feet. Now here is a good example of drawing it out. So draw out your room, and you'll have 12 feet by 15 feet, making an area of 180 square feet. But carpet is usually sold by the square yard. How many square yards of carpet do you need? Okay, well, back a while ago in the previous slide, we actually said feet squared is how many yards? 1 yard squared is 9 feet squared. So since we have 180 square feet, we have to divide that by 9 to give us yards squared. So 180 divided by 9. So we have 20 yards squared. And notice how many yards squared of carpet do we need. So that's what we want. That's our ending unit that we want. Again, the 180 feet squared times 1 yard squared divided by 9 feet squared. Remember, when you squared this, you squared the 3 feet. Because 1 yard equals 3 feet. The feet squared canceled, and you got your answer. The second example, filling a planter. How many cubic yards of soil are needed to fill a planter that is 20 feet long by 3 feet wide by 4 feet tall? So you're doing a cubic here. Notice it says cubic yards right here of soil. So we're doing volume. So the volume is 20 feet by 3 feet by 4 feet, which would be 240 feet cubed. But notice your answer here is given in feet because it's measured in feet, but they want cubic yards. So you're going to have to convert this to cubic yards. So remember, 1 yard equals 3 feet. So 1 cubic yard equals 3 feet cubed, which is 27 feet cubed. So if we start off with the 240 feet cubed, we multiply it by 1 yard cubed is the same as 27 feet cubed, and 27, the feet cubed is on the bottom, so that cancels. Oops. So what we do is we cancel the feet cubed, and notice this is on the numerator part, it's on the top, and this is on the bottom, so you're going to divide. And do you see this little squiggly equals? That means approximately. So that means you're going to round. Make sure you read the questions in your homework when it tells you to round to the nearest tenth, or 1 decimal place, or the nearest hundredth, or 2 decimal places. So when we took this and divided it by 27, we got approximately 8.9 cubic yards. All right, currency conversions. Converting between currencies is a unit conversion problem in which the conversion factors are known as the exchange rates. This is talking about money and how much the dollar equals whatever it is in another country, be it the pound, the euro, or the yen, or the peso. The table represents some typical currency exchange. Make sure when you're reading these problems that you're also seeing if they have a chart for you where they have your, excuse me, if they have their conversions that they want you to use for the problem. All right. Example, let's do gas prices per liter. Gas station in Canada sells gasoline for CAD, which is your Canada dollars, 1.34 per liter. CAD is an abbreviation for Canadian dollars. Okay. What is the price of dollars per gallon? So we're actually changing, not only are we changing Canada money units to dollars, we're also changing liters to gallons. So you're actually doing a double conversion here. Use the currency exchange rates on the previous slide. So this one's telling you use the chart that they gave you. All right, so we use a chain of conversions to convert from CAD to dollars and then from liters to gallons. The currency conversion, if you look back on the chart, is 1.005 per CAD. And there are 3.785 liters per gallon. So we're going to go with what we start. Remember, the first thing you always put is what you're given. So we've got 1.34 CADs per liter. So 1.34 CADs per liter times our conversion. So it's 1.005, and notice this is in dollars, per COD. So we're going to change this one first. And because we want the CAD to cancel, CAD is on the bottom here. So we're going to cancel that CAD, and we're in dollars now. And then we have to make sure we get rid of the liters. And we know that there are 3.75 liters per gallon. Since liters are on the bottom, we're going to put liters on the top. So your 3.785 liters per 1 gallon. And then this liter will cancel this liter, and you're left with dollars over gallons. Notice when you go across, you're going to multiply these as you go. So your CAD canceled, your liters canceled, and then you get approximately $5.10 per gallon is what it is in Canada.